Hello, everyone. So we are very excited to be here. So my name is Abhishek Singh. I work at Apple in Cupertino, California. Over a decade working in enterprise search, external search, and wide variety of corpus and data.
Likewise, very excited to be here and definitely a lot of familiar faces. I'm Atri. I've been in research for many years now. I'm a Solar and Lucene committer and PMC and have also dabbled with OpenSearch and when it used to be Elasticsearch. I work with Abhishek on similar enterprise search problems, and we are here to tell you all about the challenges that we have seen and how we have solved them.
Okay, so the agenda for today is what are the unique challenges, how we go about ingestion of those challenges, retrieval, and at the end evaluation. So let's talk about the challenges. So enterprise search it's way different. Why it's way different is because enterprise consists of wide variety of corpora. You have legal team, you have procurement team, you have sales team, you have travel team, and so many teams that has data which you need, and there is no way, unified way to retrieve that data. So for example, when I'm traveling here, I will have to book my travel. I want to know all the travel policies. I want to know if I need a visa or not, what would be my per diem and everything. And just getting that data needs me to go through these different places and find it out. And why this becomes a challenge is each data is owned by a team. So they understand their data well, but they don't understand the universal standard. So their data is in silo, they lack schema, there is a different access control on those data, it changes, it's completely fragmented, and now what has happened with RAG and LLM, you build all those chat and conversational system. So earlier what used to happen is when you search for something, you go top 5, top 10, you pagine it. Now with LLM in question, you need to be very accurate on top K if you want your LLM to answer it well. You can't have a leverage, okay, you can paginate to next page and do those things. So this is a typical architecture. I assume most of you will know there's a different kind of data that get crawled or indexed or vectorized or maybe lexical. You put RBAC while ingestion. You want to make sure the data is protected. And while query time based upon your strategy of indexing, you apply the retrieval strategy. So corpus ingestion. So now this is where everything starts. So when we talk about corpus ingestion, some of the data might be, let's say, structured. And in the structured part, one team identifies employee as employee ID. The another team identifies as EMP ID. The third team identifies employee underscore ID. And they might have different schema for the same employee to get data for me. So what happens with that is you have to work closely with those business partners to understand the schema and apply those SQS or schema.org kind of technology where you try to go schemaless. So you can ingest wide variety of data into your system, and maybe you identify employee as an employee entity rather than an ID or something else. You normalize it. The other way to achieve that was that you try to come up with some kind of embeddings or BERT approach or LLM approach to understand those columns and try to cluster those columns together and then ingest it together. So which, if you go in down that path, we have seen like 60 to 70% you are able to automate things, but you still need some kind of domain expertise to help you to understand those different schema. Now, generally, the pipeline would look like an Airflow or Daxter. You will go with schema versioning technology, real-time ingestion, CDC, Kafka, or Flink, whatever. But what we have learned is that this schema stability, they will never be stable. Enterprise system will keep on evolving. You will always have issues with schema. Something will break. The quality won't work. So you need to have a good amount of validation on that schema in terms of structured data as well as write notification. Now we go to unstructured data. Now this is a different beast altogether. So when we come to unstructured data, some teams use, let's say, Box folder as their own content management system. They refer to Box, they search in Box to find out the data, what they are looking for. But when you want to make that data, you can say, much more systematically into your system, it requires a lot of step. And I've seen here in Berlin Buzzword, there was a specific talk on parsers, then there was a specific talk on, you can say, hybrid approaches, some re-rankers, and I think there's a parallel talk going on, which is on RAG. So consider that all those specificities come here and try to optimize it. So you can start with a normal parser, you can go as sophisticated as OCR-based parser, and you can have a system which has some hybrid techniques of parsing, fallback strategies. But overall, what you will see is parsing in unstructured data will become very, very complex problem to solve. So what we tried is we created a document ingestion system which first checks the meme type of a data. Based upon meme type, it assigns what kind of parser I have to go through. So PDF parser will go in a different parsing style, then Keynote parser, then other parsers. Now let's take example of PDF. So when you ingest PDF, now PDF can have charts, it can have images, it can have tables, it can have many more components. So what you do now? So you try to first identify the section. Okay, what is the section that I want to take as an atomic section? And you can identify through layout and structuring, or there are many strategies available. But the bottom line is when you grab a table, you identify a table, you try to go very specifically parsing the table. When you grab a chart, you try to go very specifically parsing the chart. In some cases, people have used LLM multimodal technologies to parse, but you need a very specific component to parse each other. Now, once you have parsed it, then there was a talk on chunking, that there are tons of chunking mechanism. What we have seen is semantic chunker overall works pretty well, but based upon the corpus, you have to decide how you want to approach it. So for example, if it's a table, you want to see before the table and after the table, it makes relevance with the data itself. Now, things become much more complicated when you have legal kind of document. Now, legal has terms all across the document. If this happened, do this. If that happens, do that. Your rights here is this, your right there is that. And same goes with procurement. Procurement has so many legal terms. So your semantic chunking has to adopt what domain you are targeting for and what kind of data you are ingesting. So these are different chunking strategies. Like I'm assuming everybody knows there's a lot of talk on chunking in this case, so we'll skip that. Now, what we did was we started with the dual indexing approach. We were very open about BM25 as well as vector indexing. We wanted to make sure that hybrid structure in the sense of where exact match is very important. We have a lexical layer, and wherever we need vector semantic, we have a semantic layer. Then the other thing that we did was we associated a lot of metadata with each chunk, because this helps us later in identifying any kind of boost we want to do later, or we want to suppress a result because of content level RBAC and whatnot. And one thing is token entropy. So what it means is, if across a document, it's certain chunks are repetitive. It might happen in terms of header and footer. It might happen in terms of many scenarios. So you want to give lower weightage to that kind of chunk. It should not come higher in relevance. And then third was deduplication. Because it's an enterprise system, people have a lot of duplicated data across domain. You want to just deduplicate and return it. You don't want your LLM or your search engine to have top 5 result, which is same. So this is what we come with is corpus-aware index architecture. What it means is it is very open about you want to do lexical index or you want to do vector index. What we did was, based upon the corpus, we created a dedicated pipelines that is very customized in the sense of understanding that corpus for higher accuracy. And when the data comes, it gets distributed based upon its file type, the domain, or if we don't know the domain, what is the default domain, that kind of system was built. And then after that, the magic should happen in retrieval. So Atri will talk about it.
Thank you, Abhishek. So to continue with the point that Abhishek left off on, the entire magic happens at retrieval stage. So till this point, what we have built upon is how do we get to our data? Because eventually what really matters is what the end user is seeing. To Abhishek's example, if when we were coming here, we search for travel policy. Now, travel policy goes into travel, has different implications for myself and Abhishek because we are in different geographies. There's a visa aspect to it, there's a legal aspect to it. How do we identify and get you concrete information from all of these corpora without having a bias for one or none of them? So we go back to the architecture that Abhishek was showing earlier. So with this corpus-aware sharding that we have, we extend it to become multi-intent inference architecture. Now, what does multi-intent mean? As I just mentioned, when you search for travel policy, we identify your intention to be, or intent to be, on 3 main corpora. Now, it can, of course, go across multiple corpora, but we have to take the high confidence ones, because otherwise we would be fanning out a lot and we would be running into a lot of noisy signals. So we identify few corpora that make sense for us. Some of them just might be good with a vector store-based search or semantic search. Some of them might actually have a hybrid model where you have a lexical index, you have a vector index, you go search across the both and do a hybrid search, which we will talk about in just a minute. This will ensure that not only are you getting relevant results, but you're getting relevant results across multiple intents. So we are able to capture and give you the information that you need. Because in the end, it's about the objective of the query and what you see on the end user result. All of this has to work in alignment with getting you the right information. And that will most likely, in enterprise scenarios, not happen with a single corpus. So I just mentioned hybrid search and score fusion. So this becomes absolutely necessary in situations like these, because we have multiple corpora. They have different schemas, different storage layouts, even different indices. As Abhishek mentioned earlier, some might just have lexical indices, some might have split indices. Doesn't really matter. We have to have a model where we can retrieve and merge across all of them. So we come to fusion-based retrieval. Simple example. A query goes to vector index, one goes to a sparse ngam, BM25, get those documents, get the top K results, merge them. Now, merging again is a complex process. As somebody said in today's morning's talk, fusion and re-ranking is hard, and that's the gospel truth. We will talk about it in just a second. But in this scenario, we get the top K results from both of them, and then we could do as simple as a static weight-based reciprocal rank fusion. And once we get that data, we send it to LLM. The LLM takes the top N context and formulates an answer that eventually gets sent to the user. The idea here is that the top N that we get across top K results from both of these sets should be relevant enough so that the final result has all the context that the LLM needs to construct the final answer. So one point that I hear quite regularly on this is that prompt engineering is very important here, and I agree. The prompt that gets sent to LLM is very critical here, because if the prompt is wrong, you will end up with something very different. But with the prompt, the value of, with the right prompt, the value of the top N accuracy even gets higher, because if your context is wrong, no prompt can save you. So one other problem that we run consistently into is, especially when we are dealing with a high diversity of corpora, we have just too many corpus to deal with. They all have different schemas, different content layouts, but many times the semantic meanings might be overlapping. What might happen is if you just focus on, let's say, a static RRF or one methodology of fusing results, you might miss out on diversity. Now, what does diversity mean? Imagine that you have a manufacturing system, where you have parts being manufactured and then being sent out. Now, if I want to search for some specific terminology, I might get overfitted to one corpus, let's say production logs. But I might have some relevant information in bug reports as well, or maybe user feedback. So now, not only do we have to balance relevance, we also have to ensure that we are getting enough diversity in the final results, because it's going to LLM. It has to provide the most concrete answers possible. The interesting part starts as to where do we find the trade-off in terms of relevance and diversity. Do we sacrifice relevance for the want of diversity? What happens when we get maximum results from one corpus? It might be that it's way too much relevant, or it's just the model was too overfitted so that all the embeddings were in one direction. So that is where some strategies that we have tried out will be shared. So as mentioned, we have the query might overfit to one domain, and we might have redundancy. So some of the techniques that we have tried earlier are subtopic entropy maximization. So as Abhishek said, if you have too much entropy in some terms, or some chunks are just present everywhere, you reduce their value, you penalize them, or maybe you are getting low entropy results, but from new chunks or new semantic values, you want to give them a boost. Then, of course, if you cluster semantic embedding, so as Abhishek mentioned earlier, we have that ingestion time clustering of embedding. So we use that to identify if the majority of top results are coming from one or two chunks or one or two clusters. If that's the case, we penalize them, or we look at more discovery modules to identify other clusters or other semantic components where we can get results from. I've already talked about boosting novel corpus. So if you see a novel corpus in the re-rank phase, which might not be in the top n, but has a moderate relevance or moderate score, we actually boost it so that the novelty factor or the corpus spread across K remains high. An example of that, employee grievances can go to HR and compliance, but might be overfitted to HR simply due to the terms. And we just talked about system design queries, where the terms or the semantic meaning might be spread across multiple corpora, but the query might overfit to one. Coming to the how do we actually achieve this? So a standard way of getting into the final ranking phases or the actual quality of results is through ML-based re-ranking. Now, what does ML-based ranking mean? It has, again, we have multiple options on the table. We'll go into some of them. But basically, after you get the lexical and vector scores from your individual parts, and you have metadata features associated, you basically send it to models. So now they can be multiple kind of models here. They could be very lightweight, like light GPM, cat boost, cheap GBTT models, or for higher relevance or for a smaller final result set, you could for distill transformers or cross encoders, which we will talk about in a bit. And then you basically keep training those models with training data that is beyond your immediate corpora. For example, click logs, dwell time, hard negative sampling. We need to ensure that the model is up to date and it knows the current signals which are used in real world. So the objective is to optimize these user metrics, and that is where the models focus. One aspect here that is very interesting is that sometimes we also use KG-based features. KG is a knowledge graph. So for enterprise systems, knowledge graphs become very important in terms of synonym identification or query expansion. We'll talk about that in just a second. So now, in the world of re-ranking, we have to ensure that we maintain the quality of results, but have a diversity boost. So while our primary goal continues to be relevance, but we have to explicitly balance it with the novelty of data that we have across multiple corpora. So the corpus spread across at K, which is the metric that we look at, has to be high, but the relevance cannot take a hit. So how do we do that? We basically maintain the quality of our top K. So if we have very high confidence in certain results, we keep them because relevance does take priority. But for, let's say, top N to top K, which is basically medium quality results, we do inject a diversity factor. We take factors like entity co-occurrence, diversity, addition. Look, if I take this result, what kind of diversity score is adding to my results? And that is a factor that is accounted for in the final ML phases. Yeah, I think we already talked about this. So a very standard way of doing re-ranking is there are two standard ways: bi-encoders and cross-encoders. I think everybody here would be aware of them, but I'll just quickly run through. Bi-encoders encode queries and documents independently, and then at runtime, at re-ranking time, compute across a cosine product or dot product and give final results. Cross-encoders are more enriched, and they can capture cross features or deep token features, but they mandate that the query and the document be encoded together. So they are great, but they are slow, so they have to be given a smaller final subset, whereas bioencoders are cheaper, so they can be given a larger recall, and then they can basically create a pipeline for the cross-encoder to look at. Or if we are in a latency-sensitive environment, bioencoders can be the way to go. One relatively recent technique that has come up is rack fusion. Rack fusion basically takes the concept of rack to a new level where retrieval augmented query expansion happens. So in the first phase, you look at you retrieve top documents and you use that to expand the query into multiple focus queries. And then that reformulation approach helps boost both relevance and diversity. And then once that happens, the second phase basically fetches the final documents from the reformulated and expanded queries and then merges results for a re-ranker input. What this helps with is that the context becomes much more expanded, much more diverse, can target multiple corpora, and we can have signal-based enhancements here. Of course, rack fusion does have a latency consideration to it, so it should be used with caution. But rack fusion continues to be one of the ways which will help balance relevance and diversity, even if you're dealing with multiple diverse corpora. So we talked about knowledge graph. Where does knowledge graph come into picture and how do we utilize it? So in enterprise systems, knowledge graphs are very important because imagine synonyms or related phrases that are associated with each other across corpora but might not be immediately visible. How do we capture that? For example, I say time off, but that also means vacation or time away. How do we capture these kind of fundamental, and this is a very simple example, there might be semantically similar elements that have no lexical overlap at all. How do you capture that? One of the
example of that is, let's say you have two different teams which has the same error code in their documentation, error 129. So now for one team, error 129 means something crashed, or for the other, 129 means it's not working, something like that. So how you will manage that in enterprise context?
That's a great example. So to his point, in these kind of scenarios, what we do is we used knowledge graphs for entity extraction. So we have basic name entity recognition, we have LLM tagging, and we create the KG paths that allow these kind of resolutions to happen at query time. We also store the node embeddings alongside chunks so that at retrieval time, we don't have to do a two-phase retrieval. And that allows us to expand the query using these kind of techniques. So basically, the KG will allow us to identify these kind of scenarios, saying that, okay, this error code might have different meaning in different context, or the reverse. You're talking about, let's say, GPUs, that might mean NVIDIA or something else. So these are the kind of expansions that KG helps us with, and we have definitely seen that to be very valuable for diverse multi-headed corpora, but that have semantic overlap, but actually might have different lexical terms, or the vice versa. You have exactly same lexical terms like Abhishek example, but they mean something very different. The other one, as we mentioned, we use the indexed data to during query time to expand with KG neighbors. You can use edge weights, you can auto-learn edge weights during traversal, or with user feedback, the same feedback that we identified earlier, dwell time, CTR, the standard metrics. And we can also use that to expand stuff like product hierarchy. So let's say if you have a product hierarchy and user targets a hierarchy at sub-level, but you want to add more options or more queries, we can navigate them using a knowledge graph, get more relevant query expansions. Not only will that help with the corpus diversity, but also helps with latency, because you can use that for your ANN pre-filtering. So not only will ANN query get faster, it'll also look at subcluster of embeddings that are more relevant to a specific user intent. So yeah, so again, walkthrough of how a knowledge graph for enterprise looks like. Here the query understanding layer, which we talked about earlier. Here the user query. We do store the node embeddings alongside chunks, so you can do node search right there. You can identify the relevant nodes within your knowledge graph. They go to a re-ranker, and then you basically have subgraph. So the subgraph neighborhood allows you to expand your query with hitherto unknown terms or semantic frameworks that might not be immediately discoverable. But because the knowledge graph has been built over the entire domain or entire multiple corpus, it is able to identify those subgraphs or those neighborhoods that are relevant to your query, even if your embeddings or lexical search is not able to immediately identify that. So we have what we use for is technical components, entity linking. We have path ranking. We can align query with a subgraph. So once we discover a subgraph that is relevant for your query, we align your query with that, expand it as a part of query expansion. We add more context. So the context that finally goes to LLM can be enriched with it. We can even use that to give feedback to the evaluation layer to ensure that we are looking at the right terminologies given the original query intent. So this merging of query intent and the query with the known possible subgraph or neighborhood that is identified by the graph is super useful in all scenarios. So while we continue innovating on this, some of the things that look very promising for enterprise search is personalized corpus routing. So for users, we wish to understand user affinity. What does the user really want, or what do demographically similar users want? So if we can bucketize that, we can learn affinity vectors that will help us have a better targeting at query time, and we prioritize user preferred corpora during our scoring methodologies. Similarly, for our graph, we want to use the same feedback that we use to train or identify train our models and identify the quality of our search system to grow KG edges. We want to boost re-ranking using neighborhood relevance. So your re-ranking should also take into account the neighborhood relevance of the subgraph that was identified by our KG. That will really help boost similar terms that might not be immediately available, but are very semantically similar to what your user's initial query intended to get. And finally, intent-aware pre-filters. I briefly touched upon that, but as we go to more diverse corpora, it is inherent that we not only focus at the overall quality of results, but also do corpus-specific learnings and embeddings and ensure that each corpus, while giving the best results possible, is also fast, because we can't have long tail latencies here. So intent-aware pre-filters help reduce the fan-out, lower latency, and ensure that for approximate termination, we are looking at the most relevant set of clustered embeddings first. So now I'll hand off to Abhishek to tell us about how role-based access control takes a seat here.
So I believe by now we have gone through a lot of slides, so I'll summarize a bit so it's much more clear for all of us. So what we approached is we try to identify the domain and try to build a corpus indexing based on that domain. For structured data, we try to figure out how to go schema-less. It is schema independent at max. And for unstructured data, what are the best parsing technique for a given kind of domain, for a given kind of data type that we are consuming, so that when people wants to retrieve at the beginning using KG and intent classifier, you know which corpus to hit, get the data, figure out the re-ranking mechanism, and send it to the user or send it to LLM. In some cases, KG will also help you to filter, to do other things. But all of this thing will work very well independently. But when the entire system works together, one of the main constant that comes in enterprise is role-based access control. So what role-based access control means here? Role-based access control means what kind of data I am entitled to see. So in many cases, let's say, for example, HR of a company has much more access than an employee, than a manager, and the data under the hood is same. How that impact relevance, how that impact your overall strategy. Because we don't want to leak an information using this engine which a user is not supposed to see. And there can be graph-based RBAC too. So graph-based RBAC is your role-based access control is based on your company or your team or your group. So this, how to use this graph-based RBAC, and then fine-grained RBAC. This is one of the most, I will say, complicated form, because what happens within a file, within certain file, there is a paragraph which only HR can see. So what it means is you have to change your entire chunking strategy for that kind of domain, because you have to make sure that when you are chunking, that particular chunk should go as a one entity with a different label on it. So this is what I was talking about. Now some of the slides are not here, but that matters a lot in enterprise. So this is about security. Now you might have a requirement of indexing a data which is very critical to business. Only a certain business can see this. It can be financial report, it can be how good or well a company is doing. Now what happens with those kind of requirement, you need to encrypt the data everywhere it goes because you don't want system admin to have access to it. Now what it means is if you are adopting certain vector techniques and that vector rotation, it does not work with vector rotations or it does not work with homomorphic encryption, then that vector, no matter how good those embedding models or vector techniques are, it is not useful for you. In some cases, people have used LLM or higher embedding models like a small language model in GPUs. But what if GPU encryption is not enabled? So any admin can dump a data, you don't have a secure enclave. So building this enterprise system requires to take into account all of these complicated scenarios for the security. So we are in the last 10 minutes, so I'll try to finish this. So again, when you come to evaluation, there is no one technique that will help you with the evaluation. You have to figure out what is the best way for evaluation. One of the things we realize is, in some cases our answer was exactly right, but it was like yes or no. And when the similarity score were evaluating it automatically, it was a long sentence that mean yes only, but it was going down the path of no, like reject. So if you see, you can start with a common approach of retrieval, like NDCG precision, and behavioral, like how much users are looking at it, who is clicking on it. You can have a separate evaluation considering ACL in mind, because I might be asking a question where system can give you the answer, but ACL is not letting you see the answer. So for a user, it is a bad experience, but it is enforced by system. Now, subtopic coverage, you have to relate topic, you have to figure out is the topic and the subtopic are discoverable to it or not. We strongly believe domain teams need to be a part of this. They need to create these test cases, and diversity and challenge set is as important as domain team. Because what happens is, in today's world, everybody will go down the route of LLMs, and LLM's judgment or LLM answers, they will look very true, they might not be true. Only the domain expert can validate that. So in this case, if you see in some of these techniques, what we saw is the issue was at parser. You need to change the parser to behave differently in merging certain columns of a table. As soon as we change it, we realized that we fixed 23% of the failure. And edge case coverage is very important because you know it might reveal a longer problem, a much more deeper problem into your system. So you have to make sure that some of the edge cases are always taken care of. And user-driven signal. Always ask the user. Always ask the user implicitly or explicitly how the system is working. Now, this is very standard. You use system of records, source of record. You collect all the logs which you are allowed to collect as a part of security. You use them to figure out implicit feedback, or you can use synthetic evaluation using LLM. You create for each chunk, create a query pair, what it can question, what it can answer, and use that into your synthetic data. Now what happens with this is LLM as a judge concept comes up. Like now you are using LLM as a judge. But LLM as a judge will not work out of the box for these kind of different domain. What you have to do is work with your domain partners to come up with those golden set, and then compare that golden set evaluation against LLM as a judge evaluation and try to align your LLM towards more human evaluation. So this is a very important step for the alignment part of it. It takes a lot of work to align LLM to answer as close as human, and that's how you can decide to make your pipeline automated. Until then, you have to work manually on it. I think this is pretty much. We have last 5 minutes left, right? Yeah, we'll go to question answer then.
Okay, so thank you very much for the presentation. I guess we'll have some question maybe. And in the meantime, I will check online. But I didn't see any online question yet.
So maybe we did very well or very
question
good,
from
right?
Charlie.
Hi, great talk, thanks. You talked about how you're doing sort of query intent recognition to identify, if I get this right, identify the corpora most likely to answer the user's question. What's the risk there of effectively excluding potentially relevant results by, again, you're only looking at, I think, the three top corpora. You know, if you get your intent recognition wrong, how do you address that risk?
So yes, and because it's mostly machine learning based, so it will never be right all the time. So what we did was there were certain techniques that we took. In some cases, it's pure A/B testing, where we can see low amount of queries, are they right or wrong? Do the A/B testing on that, figure out. The other thing is we disambiguate it. So what it means is when the query comes in and your confidence is less to answer it, so you try to go back and try to disambiguate with the user. This is one technique. The other technique is, okay, the question comes in, I'm not confident about answering that, send to all the corpora. Bring back the result and then try to do more magic on your cross-encoder ranker or re-rankers to see how it works. Even after all of that, you will see some of the queries are underperforming. That is where you will bring back your domain expert and humor annotators to see what's going on in the system.
Thank you. Any other question? Yes.
Thank you for the presentation. One question about the knowledge graph construction. Is there a way to get duplicate nodes? I mean, nodes referring to the same entity. Is that really?
So yeah, great question and a very pertinent problem. So yes, there are multiple cases where duplicate entities do make their way, and that does pose a problem. But in some scenarios, we keep them because they might just represent semantically different entities. Like you might talk about a hardware component as a component to a bigger product, or you might talk about it in the frame of some support program. So you might just want to keep them like that because they'll have very different attributes. In some other scenarios, there are known techniques for entity merging and identification, and there are many research topics on that. But you can use semantic neighborhoods, you can use node embedding clustering, you can even have LLM context-based entity duplicate detection. Of course, you have to first apply some NER-based methodology to reduce the recall for that, and that cannot be real time. It has to be done as a vacuum process, as a periodic batch-driven system. But those methodologies do help a lot. And it's the same problem as any other ML model, right? So you have to ensure that you are measuring its quality, and there are multiple KG metrics like structural quality, semantic quality that you can measure to understand the pre and post impact of your merging. So yes, semantic merging, semantic deduplication, sometimes human-annotated deduplication does help. And sometimes you just want to keep it as it is.
And there were duplicate in the sense, as we mentioned, what we have done is we have made RBAC as a core of the component, like each chunk, everything. So you might have duplicate entities on graph, but their RBAC is different. So it is stored as a part of that node. So when the query comes in and when it resolved to the role-based access, you actually get one.
Thank you. Any more question? Okay. So thanks again. And
On time.
yes, on time. Okay.